Okay guys, so today we're going to look at how we can evaluate expressions with logarithms. So let's try to do the first couple questions. So we have 10 raised to the log base 10 of 100. So let's figure out what this is. Log base 10 of 100 equals some number. So 10 to the y is 100. So what's y? Y is really 2. So this really means 10 squared equals 100. So let's try another one. Let's try number 3. So we have 5 raised to the log base 5 of 125. So log base 5 of 125 equals some number. So 5 to the y equals 125. So y is 3. So then again, we just end up with 5 to the third equals 125. So in general, let's think about what we're doing. We're saying 5 raised to what power gives me 125? Okay, that's 3. Now 5 raised to the third is 125. When these numbers are the same, you're just going to be left with the 125 or the 100. So to generalize, here we're going to get 100, and here we're going to get y. Okay, now let's look at how we can use the 3 properties of logarithms to rewrite like 5 through, actually we have a bunch of questions like this, but starting with 5, we can use the properties of logarithms to rewrite these logs and then use this other information to get values. So we know that log 20 is really the same as log 4 plus log 5. Because when you add logs with the same base, you put them together into 1 and multiply. So this is really the same as a plus b. In each of these examples, we're going to try to rewrite the log using log 4 and log 5. For log of 5 divided by 4, that's really the same as log of 5 minus log of 4, which is really the same as b minus a. Okay, let's look down to 10. So for 10, how do we get up to 10? Well, it can't be just 5 and 4. Really, we'd need to multiply like 5 and 2. So 4 to the 1/2 will get us to 2. So this is really 1/2 times log of 4 plus log of 5. So this ends up giving us half a plus b. Okay, let's look down at question 10. Question 10 is pretty challenging. So 5 to what power will get us 625? If we just keep multiplying, we'll see that it's 4. Now we need to figure out 4 to what power gets us to 2 to the 1/2. We can rewrite this so that it's 2 to the 2x equals 2 to the half. So that means that 2x is a half and x is a fourth. So 2 to the 1/2 is really the same as 4 to the 1/4. So this is plus log base 4 to the 1/4 minus log of 4 to the 1/2. Right, the square root of 4 is 2. Okay, so now this is really the same as 4 times log 5 plus 1/4 times log 4 minus 1/2 times log 4. Okay, so this is really the same as 4b plus 1/4 a minus half a, which is really 4b minus 1/4 a. Okay guys, so now let's look down to a different kind of problem at number 22. And we need to remember that whenever we want to solve an equation that has a variable in the exponent, as long as we have the term with the variable in the exponent alone, we can take the log of both sides. What that allows us to do is to put the variable in front and then divide. So here, we end up getting that x is the same as log 80 divided by log 4. And you can just put that in your calculator. Okay, let's look down at one that's a little trickier. So like 23. So we need to get everything with the x on the same side and everything else on the other side. So we could start by dividing by 2, and we get 3 to the x equals 3 halves times 2 to the x. Now to cancel out timesing by 2 to the x, we can divide. So we have 3 to the x over 2 to the x equals 3 halves. Well, x is really the exponent for the whole thing here. So this is really just 3 halves to the x equals 3 halves. So now we could take the log of both sides and put the x in front. So we have x times log of 3 halves equals log of 3 halves. You could see now that x will just equal 1. And if you look back to the equation, it makes sense that x would be 1.